Hi guys, today I'm going to introduce you guys to this auto transformer. It's a static auto transformer. There's no moving parts inside which helps my systems a lot, my solar systems a lot. This unit is a input, as you can see. Maybe you can read it because it's in the corner. Input is 220, output is 200. Why I'm doing so? Let me show you. See, let me switch on the light first. Okay, the incoming now is 236, but of course there's some variations. Usually it's 240 something, which is I'm staying in Vietnam, so this it have to be 220 around there. It's still within the Vietnam standards, but sometimes it's a bit too high, and it can surge up to 270 something. And sometimes it falls down. But electronics will work better with a lower voltage, and it still works because electronics things all work within a range of voltage. So working at starting off with 20 volts, this auto transformer has a 20 volts reductions. So with a lower voltage, so when it surge, I still have a much more bigger safety margin. If it go lower, no problem, the electronics will just cut out by itself. All electronics will just cut out, just say low voltage, it will not function. But high voltage, when it surge, it just go through within microseconds. If it's over the range of the electronics, it will just has something is burned inside. So this actually is this step down auto transformer. It's a static one. Why I choose a static one instead of the servo inside? Because auto transformer actually the reaction time is a few microseconds, or that's the fastest one. But a surge can go much more faster than that. So meaning it's a surge actually has already go through the circuit. Then the auto transformer will start to react. So static one, there's no reaction time. It's always there. It's constantly there. So when the input coming in is always cut out of 20 volts. Mine, this one is cut out about 19 volts. I tested out about 19 volts. You see incoming. Let's see it again. 237. So after that, so now come down to this meter. Let me adjust myself. I'm not sure you can see it. Let me on the LED light. So 209, but it is not accurate. I have to add 2 volts. 211. It's about 19-20 volts range. This actually save the electronic. Besides saving the electronics, let me zoom in back. Saving the electronics also save power, because example, if my washing machines will start working at 100 watts. When it takes 100 watts, if divide by it will divide by the voltage of a lower voltage, so it starts at a lower voltage, meaning it start working at lower voltage. That means it starts saving power instead of using a high voltage and have a sudden jerking and all that things. Okay, the second thing I'm going to introduce you guys is this tool. Let me have a minute. This tool thing. It's called NTCs. So there are two models. I use this model. You guys can read it from the screen, right? Yeah, I think so. Only on the screen. It's a NTC 2.5D-20. This I use it from all my air condition unit at the compressor side. Only on the starting coil, not on the run coil. Later I'll open up my AC compressors to let you see how I connect them. This is to limit the current, startup current from the compressor draw. So the start current is lower, and you have a much more smoother startup for the AC. It's useful for the situation where you are using off-grid or your AC is on a trailer. You don't have so much power. You need to lower down the surge current, because surge current may be three times, maybe to 7 times of the run current. This you have to search for the models for that that's suitable for you. This one works for 220 volts, depending on the area and the amount of current you need. This model exactly will pass through about 12 amps of power. Of course, you can double it parallel, but not recommended. So another one is this one, also NTC. So this is a 74D20. I use it for the freezer compressor side, also on the startup coil side, also to lower the startup current only. I can clearly hear the compressor startup. It's a much smoother sound than not using this. So let's go to the rooftop and open up the compressor to see how I connect them. Hi guys, this is a AC unit. All my AC units is installed with this so-called NTC. Okay, so when I open up, you guys open up, you can see this is old type. Only the old type can use, not the inverter type. So you can see this capacitor. This is a start and run capacitor. So there's three legs, called 3 legs. This is a common, of course. You can see the three of them, the fan and the compressors are all connected to this. So this should be common. And one of them is run, and one of them is the start current. So as you guys in the American side, this will be the home side. So you can see I'm connecting in series to the home side. Yeah. Exactly, NTC 2.5D-2. So this is just a simple thing to lower the starter currents. After starter currents, this will be cut off by the contactors, and the run current side it will continue. It will not lower the run current consumption, only the startup side, and it's not recommended to connect this on the startup side and on the run side coil of the compressors, because the system is optimized. It's optimized by engineers to run. Only the startup side, it will have a surge of a high current 3 to 7 times. So this will lower it and run it much more smoother. So for safety, please refer when you open up the casing. Behind it, there's a connection drawings. So there are two models. You can see one is a M1F. This should be the fan. M1C is the compressor side, and three wires also, and a contactor over this side. So okay, these are the Vietnam letters. So there are 3 run. See, R, run, S for start, C for common. So always connect at the R side, run side. No, S side. Sorry, connect on the S side, not on the run side. That will lower the startup currents, and only works for the non-inverter air compressors. Then always cut off the supply, electric supply, before opening up. All these are safety measures you have to take yourself. Okay, thanks everyone. Hope all this information helped you guys.